So now you know what is discontinuity. So sometimes I call join, sometimes I put discontinuity, but the meaning is same, is similar. Yeah? So okay, intact rock. So when we discuss discontinuity, intact rock cell. In previous chapter, we discussed on intact rock, which is lab test. We conduct this test in the laboratory. So the effect only on the arrangement of minerals. For example, the foliation. But it's difficult to get intact rock or sample that have joint. Difficult because when you are, for example, you want to coring to get the sample in joint area. For example, this is joint rock. We have joint. You want to do sampling in this area. So let's say we do coring. So normally this area is weak, and then your sample is break. That's why you get unable to get the dimension that you need for this testing. Yeah? So that's why we are study rock mass. So we are influenced by the discontinuity, and also we can resolve the issue of the scale. Yeah? Scale effects. Okay, meaning representation of these slope rocks. Okay, this is just to show you how this discontinuity affect the slope failure. They show the failure happened in 2000 August until February 2005. This is in term of size. This is yeah. This is very. This is your road formation somewhere here. Road formation. So this is a valley. These are your mountains. This road is between Poslim to Kampung Raja, Cameron Highland. You can see the failure happen here, starting here, and then they make remediation. So until 2005, you can see here all this slope is already the construction remediation up to this top of the mountain. So you can see how severe this failure. For information, this level to this top of the mountain is 200 meter. 200 meter, and this valley another 400 meter. 200 meter. Total is 400 meter. So this is a huge slope. I think this is a huge size slope in Malaysia. The largest slope in Malaysia lah. Man-made slope. So, but the problem is the slope is still failure, keep moving because of the material of this area is highly fractured due to this. This is material is metamorphic rock type of phyllite to schist. So they have very fine foliation. So you can see the movement of this is the model of the slope. What happened is we have a few joint and foliation toward here, and then we have a few fork, and then okay, this is how the movement of this. Okay, now you understand the discontinuity is very important in rock mass investigation. So I will show you the properties of discontinuity data, which is part of that, yeah, roughness and filling. Okay, then the important thing in this discontinuity data for slope, normally we are investigate the deep direction and deep angle. Yeah, deep direction, deep angle. Okay, this is slope data. The orientation the sample. Okay, the orientation is going to determine the shape, the block, bed, positive. Okay, this is how we measure the discontinuity. We measure using compass, geological compass. we measure the dip direction and dip angle of this fracture or joint or discontinuity. But yeah, you don't have any experience to measure. It's quite easy. Use this is example of this geological compass. Yeah, so it's not complicated, very easy to use that same compass. So how we measure, since we are not the important of discontinuity, so we can measure the discontinuity on the fields. Yeah, this one just refresh what we are doing in lab 4. Lab 4 you just do the assessment, do this analysis, but you don't know where is the data come from. So now we are tell you how this data come from, which is the data come from scan line mapping. What we did in lab 4 is from scan line mapping. Scan line mapping means we are what we have. Let's say we have slope face here, whatever rock slope face here. Then we have put one line of imaginary, just imaginary line. The red one is imaginary lines. So let's say you have here. So you set here as a 0. Your distance is 0. Then you start walking towards here, and then you find one discontinuity here. So you have to measure the distance from the starting point, and then you observe the type of discontinuity with the joint for foliation, so on whatsoever. And then you measure the dip direction and dip angle of this discontinuity, and then you have to measure the persistence of the discontinuity, how long this persistent, aperture of this discontinuity, roughness of discontinuity, is any water on discontinuity. So and then you move to second, another discontinuity, and so on up to at least 100 data of discontinuity to do this processing, the assessment, the road slope assessment. Okay, this is the systematic way to measure the dip direction, the angle, discontinuity of slope. But we have another method, we call it random mapping, which is this. If we have the slope face, so we just map the critical discontinuity. Meaning that here the person that do this mapping should have experience. So once they on site, they understand or know which discontinuity is critical and need to map. Okay, this is an example of that lab sheet on the discontinuity data sheet that we use in mapping. So a few say channel depth, a lot of things. Okay, a lot of data that you need to measure. So this random mapping that I said, you just map. If you see this outcrop, literally a lot of the fracture, a lot of joint here, but they just map the critical ones. Means what mean the critical, the persistent, the persistence, high persistent, and then and also the direction of the potential discontinuity to fail. For example, any possibility of discontinuity could fail uh, with mode of planar or wedge failure or toppling failure. Yeah, by observation on the side, we able to predict this mode of failure, but need experience. Yeah? So how we process this data is like lab number 4. So we have to present this data so everybody can, if I not conduct this testing, or if you want to present to the client, So this is the best way to present your data and tell the client the condition of your slope. So by plotting the stereo nets, we have 100 data or more than 100 data. So actually they give you a statistical trend, which is they give you with 100 data. So how many set is it in? How many set of discontinuity in that slope? So based on that plot of contour, then you're able to tell the set of discontinuity. For example, here in this example, they investigate for 61 pole. Okay, only 61, so not many. So I'm not. So they get concentration here, here, and here. So the majority is 3. They got 3 data set. But if you need here, so can produce another joint set, maybe 4. Yeah, for somewhere. If here might be here, another one. This one is here. This joins this pole consideration is here. This the great circle. For this one, number 2 is here. Great circle. Okay, that's how you presenting your data. And then this is okay. Another topic is we discuss in terms of this discontinuity. We are also another information that we need is RQD that we discuss in chapter number 6, which is site investigation and geophysics. Let me stop here.